Olson. I am one of the teacher monitors with ACE. This is my 5th year doing so. And just going to give about 20 more seconds to stragglers saying, even though nobody got to say yes, we all got dumped in here just to make sure that we catch everybody, and then we'll get started. Like I said, about 20 seconds. Welcome to the Engineering and Design panel. Thank you to our 3 panelists for being here today. In a few minutes, we'll hear from each panelist about their educational and professional journey towards their current position. After all 3 have told their story, we will have a question and answer period. Please save your questions until then. When it's time for questions, type your question in the chat and get ready by turning on your video. If you are not comfortable having your video on, you can leave it off, but remember that asking your questions with your video on will be good practice for giving your presentation with your video on at Symposium. One of our goals for the summer is for everyone to step a little bit outside of their comfort zone. I will monitor the order of questions come in and will call on people to ask their questions aloud. When you're called on, unmute yourself and ask the question aloud. If we don't have student volunteer for questions, I will cold call on the individual students who asked their questions that they previously submitted on their registration form. Today, we'll hear from the speakers in this order. First, we'll hear from Draisha Brannan, then Dr. Mahima Gupta, and Maddie Trevisan. We're looking forward to hearing everything that they have to say today. A reminder to panelists to please highlight any lessons learned about your journey, but to keep your story to under 10 minutes. And this morning, let's get started with Draisha Brannan, the Senior Engineering Associate at the City of Portland, and also an ACE alumni.
Hi, everyone. My name is Draisha Brannan, or Jay or Dre, she, her pronouns. I was an ACE mentee, just like you all. In 2011, my internship was at Portland State University studying methane and greenhouse emissions. I'm going to kind of tell you a little bit about how I got into engineering. I'm currently a civil engineer for the City of Portland Bureau of Environmental Services. I'm a born and raised Portlander. So a lot of the high schools, the middle school, everything was in Portland. The middle school I went to was Winter Haven, which at the time was known as a science and tech focused school. And that provided me a lot of exposure into STEM fields and engineering and math. I was not very active as far as sports, but I was on the robotics team, and robotics is what got me into engineering. So I did Lego robotics in middle school and continued that on at Cleveland. Some of you might know the pig mice. Our team is still around, but I did first robotics competition, so FRC. I was a builder and essentially thought I was going to go into mechanical engineering from that experience. I really liked it. There's project management aspects. I didn't know it was project management at that time, but we were helping come up with solutions with robots, and we had a team and we had to delegate all these different tasks to people. It's kind of funny because later on I would become a project manager for my job. Again, I really thought I wanted to be in mechanical engineering, but I also had an interest in environmental science. So my junior year of high school, a couple friends, former Winter Haven alumni, had done ACE, the Apprenticeship in Science and Engineering. And I pretty much selected all the internship opportunities I was interested in, and I was selected for the one in environmental science, which is my other interest. I really like protecting our environment, the science behind that, and I was kind of torn between engineering and environmental science. The internship I had with ACE at Portland State University, where I was measuring methane flux emissions, pretty much told me I struggle with being in a lab all day and looking at spreadsheets all day. And it was such an experience and a blessing to be able to have that experience and know that, okay, I definitely like environmental work, but I'm not sure I want to be doing lab work. And I was really grateful to have that experience to be able to pivot and know that I could still choose an interest, but it kind of helped me narrow it down. And I feel like a lot of students don't get that opportunity, but you do with ACE, which is why it's such a great program. So that was my junior year, and I pretty much was focused on engineering my senior year of high school. I applied for only reach schools, which was a little bit too optimistic, which included Ivy Leagues and then University of Portland as my the school I was settling on. However, the settled school, University of Portland, paid for almost everything. When it comes down to it, finding college that is affordable sets you up for success later on in your adulthood, basically. Not being able to have debt and making sure that you can find that life pursuit of happiness and travel and do the things that you want to do. So I'm really grateful that University of Portland ended up working out. I made sure to search for schools that had the program I was interested in, which, like I said, engineering, not mechanical. I ended up pivoting both the combination of environmental science and engineering together by picking civil engineering with an environmental focus. I wanted to still give back, and I knew that engineering was a way that you can provide innovative solutions and what I thought was solve the world's problems. So at University of Portland, I finished in 4 years. It was incredibly challenging. Being an awesome student in high school, which is, I think most of you are ACE mentees, so you are probably have great GPAs and already are on the right path for STEM fields with the classes you're taking and having an interest in it. College and engineering courses are a lot faster paced with a lot shorter time. And so going from being like an over 4.0 student to what I thought was very mediocre was kind of a shock. And I want you to know that no matter your GPA in engineering school or math focused or any sort of STEM field, having the best GPA doesn't automatically mean you are the best engineer. Engineering school, I work with some of my peers who had almost 4.0 GPAs, and the reality is some of them cannot engineer their way out of a box. I have a higher position than some of my former peers who had better GPAs than I did. So don't beat yourself up about a GPA when you get into college, because classes like differential equations, statics, fluid mechanics, those are pretty hard. And acing them from a book doesn't mean that you're going to be able to design, and actually struggling through something is truly engineering because you're problem solving and figuring things out. So that's my big lesson there. I really was worried about finding a job with what I thought was a very mediocre GPA. So I applied for jobs halfway through my senior year of college, really nervous and anxious. And I accepted a job about 4 months before I graduated. Lesson learned there. If you go into engineering, the field and the market is really good. You do not have to accept the first thing that comes your way, especially depending on how the economy is. But at the time, right now, I think probably for the next few years, there's just not enough engineers. So I wouldn't quickly jump into a position before you find the one that meets all of your needs. I ended up being an engineering technician for the city of Portland. I'd applied for, like I said, I was still in school. They provided some flexibility to still be in school, and the treatment plant was right next to University of Portland. I just drove, instead of Lombard, I drove down Columbia Boulevard. And environmental engineering goes into water treatment. It's a whole field of that related to treating water and where the poo goes. That question of where you flush the toilet, that's what some environmental engineers do. It wasn't what I thought I was going to be doing, changing the world, but I do know that when your toilet does not flush or your sewage doesn't go to the right place, that's a pretty big deal. And without it, we would probably not have as, quote, civilized of a Portland to be living in. So it wasn't what I thought I was going to be doing, but it turns out I love it. And the field I ended up working in was construction management, which I still find a lot of alignment to the project management type of role I was doing in robotics. I'm managing teams and delegating. I get to do a lot of telling builders what to do. And that was the first 3 to 4 years of my career was in construction management. I really wanted to still continue to be what I thought was a normal engineer and get design experience. So I pivoted right before the pandemic, applied for jobs within my bureau, having a strong network really helps. The design division manager at my job was actually a former professor, adjunct professor. And he remembered me for my senior design. I made sure to have coffee with him and told him, hey, I'm doing this. I really want to learn. And if I get stuck in one field for too long, it's going to be very hard for me to leave construction and try something new. Having that network is what allowed me to interview in another bureau or in another group. And I've got opportunities in the Portland Water Bureau doing construction management of a reservoir. So Mount Tabor, you go up to Mount Tabor, see the beautiful view. There's a reservoir adjacent to it that for 12 years was empty. And I got to manage the construction, patch repair, and filling it up again. I got to work on Bull Run. So I went out of sewage into potable water, and then from there into design, which was such a great fit for the pandemic because going out into the field would have been very challenging. So I really like design for the flexibility I get. I get to work remote now. My construction experience is very helpful. A lot of designers, things look good on paper. Doesn't mean they look good in the field. Doesn't mean they can be built in the field. So having experience in multiple areas really helps a career to be balanced. And you can use all those skills throughout your career and different positions. So feel free to try things out. Y'all are young. I know people tell me I move jobs too much, but really I'm just getting new experience. And I know that Gen Z, you all are going to do the same and learn all sorts of new things. We're not like our parents where we stick in jobs for 20 years when we don't like them. You move because you deserve to be respected and learn new skills. So I think that's about 10 minutes. I guess I'll talk more if there's questions later.
Sounds great. Thank you, Ms. Brennan, for that kickoff to our panel. Next up, we have Dr. Mahima Gupta, who's the Assistant Professor of Electrical and Computer Engineering at Portland State University and an ACE mentor this year.
Thank you, Scott. Hello, everyone. I am Mahima. Like Scott said, I'm an assistant professor with the Department of Electrical and Computer Engineering. Within that area, I focus, or my research rather, focuses on power engineering. So what does that mean? Can I make it interactive, or maybe I'll just speak? Or would anybody like to volunteer what power engineering means? Does anybody know that? Quick, 5 seconds. Okay, I'm sure many of you know that, but essentially dealing with electric power. How do you get power at your homes? And more modern day power engineering is looking at integrating renewable energy sources, sustainable energy sources into our daily lives. So within that area or specialization, I work in the area of power electronics. And what does that mean? I thought to give an example of an electric car with the hope that all of you know what an electric or a hybrid car is, right? So typically we would use gas to run our engines that would make the electric vehicle, a 1-2 ton electric vehicle move. What electric cars or hybrid cars do is that they have energy storage systems in the form of batteries. It may be fuel cell if you have a fuel cell vehicle, but to convert that power or transfer that energy into motion, you need some electronic circuits. So how do you design that circuits efficiently, make them power dense, lightweight, so that your vehicles can be more efficient? And of course, how do you actually do the design? How do you put a capacitor? Where do you put an inductor? Things of that sort. So that's what power electronics is. So this is just one example that I gave out, but because I thought it would be familiar to you all. But if you look at integrating solar panels to the electric grid, or wind farms, or electric aircrafts, or things of, I think there are a lot of applications that you can think of. In fact, your phone chargers would have a power electronic device. Your laptop chargers would have power electronic device. So that's what I work on in terms of research. And I also teach courses in that area. I teach 3 graduate level courses in that area. So talking a little bit about my journey, I in fact got interested in the area of power engineering when I was a summer intern in 2009, January. That's about, I don't know, 13 years ago or so. But I happened to get an opportunity to visit a nuclear power plant. And that was really exciting because I could see an actual a giant nuclear power plant, how every electrical system in there has a backup, which also has a backup. And the complexity of I would say the electrical system in particular really amazed me. And that's where I decided, okay, I want to do power engineering. So I graduated, took up a job for 2 years in a heavy electrical equipment manufacturer, which manufactures transformers, giant generators, motors, substation systems. And then I decided that I want to learn more, be more associated with doing research and design. So which is why I did my master's and PhD from University of Wisconsin-Madison in Wisconsin, Midwest area. It took about 6 years. Then I moved to an electric car manufacturer in the research and advanced engineering department, wherein I worked in, again, electric vehicles, looking at their design, which I think was really exciting. And then I decided, okay, I want to do my own research, be my own, I don't know, CEO. So I decided that, okay, I'm going to become an assistant professor so that I can do my own research, have my own problems to work on. And so here I am. I have been here for the past 1.5 years. I joined during the pandemic, and I have been an ACE mentor since the first summer that I was here. So this is my second year, and I really like it. And I really like your questions. So that's about what I have to say, and I will welcome your questions towards the end. Thank you.
Great. Thank you, Dr. Gupta, for that. And our last panelist today, before we open it up for all of the questions, is Maddie Trevison is a test engineer from Nike's Apparel Lab.
Hi, everyone. I'm Maddie Trevison. I'm so excited to talk to you guys today. First of all, I just want to say it's very impressive that you guys are all doing this program in high school. You're already ahead of the game, so congratulate yourselves on that. So I studied mechanical engineering at the University of Michigan. When I was your age, I actually didn't know exactly what I wanted to do, but I knew that I loved math and science. I loved solving problems. And I felt, okay, I think I want to study engineering. I ended up choosing mechanical engineering because I felt it was broad enough to kind of give me some options. There are a lot of different paths you can go from that. And so that's kind of how I fell into it. So really enjoyed that in the first couple of years, just getting used to study, some of these more difficult engineering classes, working with my peers, definitely learned a lot, continued to grow, and had the opportunity to have my first kind of real life engineering experience when I interned after my sophomore year. Again, as I mentioned, you guys are already kind of ahead of the game and getting some real life experience working. And as you're in college, I would continue to seek out internship opportunities or research or whatever might pique your interest, because you won't know until you try and you're actually doing something. And my first internship really helped me figure out what I liked about working at that company and then what I didn't. So I interned for Nissan. Growing up in like a little bit outside of Detroit, a lot of engineers around me ended up going into automotive. I was never a huge car person, but working there, I learned a ton. It was my first experience working in a corporate environment, and then also getting some hands-on work, learning about engines. I was in the safety test and safety performance group, so got to analyze crash test data, and it was really, really cool. So after that, the following year, I was at my engineering career fair, was lucky to go to a school that provided resources like that. And I saw that Nike was there. And I actually had no idea that I could do engineering at a company like Nike. I grew up a sports fan and an athlete, playing soccer and basketball. And then I ran cross country and track at Michigan. So sports have always been a huge part of my life. And then now I figure out that, okay, I can combine my love for sports and my love for engineering. This sounds like a great opportunity. So I absolutely loved interning my first summer, learned a lot. And this was also in the apparel test lab where I actually work now. And so it's funny, I've actually been with this group for a few years now and have learned a lot and grown so much. And so my experience at Nike kind of taught me engineering doesn't necessarily have to be specific to something that we kind of think of growing up, like robotics or automotive. If you still love problem solving, there are a lot of other ways that you can apply your engineering skills. And when you're working for like a consumer products company, some creativity and innovation and that kind of side of engineering, you're still solving problems, but there's not always a right answer. And some of those problem solving discussions happen by thinking about the end consumer and what the consumer wants, and in this case, the athletes. And so I really liked kind of applying that mindset to solving problems and had a lot of fun. So following that internship, I did have an opportunity to go back full time. However, when the pandemic hit and as I mentioned, I was an athlete, our season was canceled. I kind of reevaluated things and decided, okay, I don't know if I'm ready to start working right now. There's a lot of uncertainty. I want to stay another year for a grad program. And so this was something that I had never had planned, but again, life happens. And so always be open to new opportunities that might come your way and never be afraid to reevaluate and kind of listen to your gut, even if that means pivoting a little bit. So I ended up getting my master's in design science, which is a lot less known than something like mechanical engineering. It was a small program at Michigan, but what it allowed me to do is they have you take some engineering project design classes, which those classes were always my favorite in undergrad. I loved working with people to solve a problem, starting from coming up with an idea to a working prototype. But then they also had us take classes in other colleges within the school. So I took some business classes, marketing analytics, a principles of management class, and I really felt like it rounded out my education and kind of set me up for the skills that I wanted in my career. I wouldn't say that I had to get a master's to be doing what I did now, but I do feel like I added tools to my toolkit and I don't regret that. So again, there are a lot of different ways to kind of get to a place. So always kind of keep an open mind with that. So now I ended up after that year taking a full-time job with the apparel test lab, and I really like it. So what I do is work with a variety of test methods. Some of them are textile industry standards like ASE and ISO, and then other are Nike specific methods that we develop based off of specific products. We test our materials and garments for quality and performance. These test methods use a variety of equipment to evaluate for mechanical strength or like tensile tests or making sure a jersey isn't going to rip, or moisture management properties. When you wear something, does it feel like it's dry fit? And we have tests for that. Water resistance, thermal resistance, etc. So it's nice to have some hands-on work, and then I analyze the data. But then the other part of my job that I really like is being able to work with our partners, which are other groups at Nike that will request that test. And that's when I have the conversation of what information is going to be valuable for you to make these business decisions. And once I present my data, being able to make recommendations about what we think is best for the product and to ensure that our athletes are getting the best quality. So I'm happy how my career path has ended up so far, but again, still kind of open to what will be coming in the future. And it has been awesome to speak with you guys. I look forward to any questions that you have. Thank you.
Wonderful. Thanks, Ms. Trosen. And thank you to the three panelists. We are going to open up the room to questions. The goal is to have everybody put their questions in the chat, and then I will call on the student to read their question to the panelists. And unless it's a very specific question, please, panelists, feel free to answer them one after the other, pile on, come in and out as best we can in Zoom, however this will work best. So I'll give it a couple moments to start the chat or start the chat questions coming in, and then we'll jump right in. So that way we have a little bit of a backlog for things. And I will do my best to take it in the order that it comes in. All right, so Lucy Lewis, why don't you start us off?
Okay, so as a female in STEM, what difficulties do you face and how do you overcome them?
I can start on that one because it's like one of my, I take that one really personally. So on top of being a woman in STEM, I'm also a Black woman in STEM. Less than 2% of all engineering majors are Black women. And I was really lucky at University of Portland. I say lucky, I had 5 other Black engineering peers, and that was a lot. I didn't realize that until I got in the workforce, and there were very few women and very few people. To my first job, where it felt like it didn't really matter that I was the youngest, the only woman in the construction field. It was more like they were excited to teach me and have someone to have that exposure and be able to help diversify the workforce. And I feel like I had a lot of mentors. But when I went to the Water Bureau, it's an older organization, and there was no one that looked like me. I was very close to quitting my job because I had no network and I was struggling. I did not like it. So I started the National Society of Black Engineers in Portland. Sometimes you have to create your own network to find a group that feels like home. And in college, I remember being a part of the Society of Women Engineers. So all those little organizations at college, like what you would do in high school clubs, are very similar in college, except they allow you to get professional outreach. They help you with resumes and like getting to know people. And then you're around just a bunch of other women engineers. It's really great. And NSBE, National Society of Black Engineers, was kind of a project I created. And we now have a network of over 60 Black engineers in Portland. We help other Black engineering college students who are facing similar isolation. It is challenging. People don't listen to you. You have to repeat yourself. It helps to have a person in your group that can be like, so-and-so said this after you've just said it, so that they can help amplify each other. Finding a mentor or somebody who's supporting you. There are more and more of us getting into the field, and it's most of the time you'll meet each other and they'll support you, but sometimes you'll meet folks and women who want to be the only one. They like being special. And so you have to identify that early on so that you know who you can trust, just like with any friend. But you're in the workplace, so it's detrimental to your career too.
I would just like to add that, yeah, I'm also a woman. So I would just like to add, I face similar challenges as Ms. Brannon. I've been told, okay, how can you test a 10 ampere 400 volt circuit because I'm a woman, right? But I would say that we need women in engineering workforce. That's how we'll change. So the only thing that I would say is that if you have a goal to be an engineer, just do it. Don't listen to anybody. You have to do it. There have been environments where I've been the only woman. I think I was a visiting scholar in Austria. I was the only woman except for the secretary to my professor. There was nobody. And I was working in a lab of 40 students. I was the only female working there. So it happens, just set a goal, do it. That's when we'll see a lot of women coming up. And I teach classes and I have less than 10% female students, unfortunately, in my class. So yeah, do engineering is what I say.
Yeah, the only other thing I would add is, there have been circumstances when I as well was like the only woman on either a team that I had in college, if it was like a project team, or a lot of times at Nissan, that was the case. And just not being afraid, even though you might think, oh, like if I ask a question, I'll appear dumb. It's no, ask questions, learn, don't be afraid to be confident, and don't be intimidated by being different. Because we're smart and, you deserve to be there. So don't forget that.
I like that you said confidence because I forgot to remind the students, feel confident about turning on your camera if you would like to say your questions. That way we can see your face as we hear your voice. So Jenny Penning, you're next.
Hi. What would you say that was your favorite project that you've ever worked on in your career?
I'll go. So has anyone been to Forest Park? Yeah, a lot of people. Okay, so it would be really awful if all those trails washed out, right? The project that I worked on was replacing a bunch of culverts to large pipes underneath roads. They were like 42-inch diameter, so you could almost crawl up in them. And I managed the construction phase of a bunch of culverts in Leif Erikson. So we got to block off the trail and lots of funny experiences with bikers, like thinking that they could go around and then end up in a ditch. But the culverts also did some biomimicry. So we put river rocks inside of them and baffles to help with the slowing down the water and to provide habitat for animals. And so that was a really fun project over the summer, and it actually got featured on NBC. So it was one of my favorite projects, one, because I got to share it with the world, and it few times do I get to be in a forest and manage projects. So that was really fun. It was before I became a designer. I don't get to go in the field quite as much now, but that was a great project.
Yeah, I would say my PhD work was my favorite project. I essentially spent like 6 years on it. Maybe that's why, or maybe that should not be the reason, but I really liked what I was doing. I think that was the motivation. I think that's why I spent 6 years and I still feel I didn't do enough. And still ideas keep propping up in my head based on what I did a couple of years ago. So that's my favorite project because I was just independent, and that was probably the first real big project I did basically by myself, of course, with an excellent mentor. So
my favorite project, I would say, is actually for my second internship at Nike. I created this dashboard that organized all of our test methods into different categories. Had like a dashboard with smart links to another spreadsheet that described all of our test methods for our partners. And I learned a new technology with smart sheets, but throughout this whole project, I talked to all of the different groups that the lab works with regularly and asked them, okay, how would this tool help you? And kind of figured out based off of how they utilize the lab, how this tool, some of the design components that need to go into it. And it was a little bit less of like the hands-on traditional engineering work that I do more in my day-to-day now, but because it was a remote internship during the pandemic, I ended up having that opportunity. And the reason why I'm pretty proud of it is that I still get requests today of people asking for access to the dashboard, and it's continued to live on and something that is a useful tool. And so it's great to kind of work on something that is appreciated by other people.
Great. So next up would be Christine Chang.
Okay, sorry, my camera won't turn on, but my question is, besides the freedom of creativity, what's another perk or your favorite thing about engineering and design?
I can go first for this one. I absolutely love the collaboration and like a brainstorming phase. So for example, right now, I'm working with an external company that's creating a new piece of test equipment for us. And so every week they come to us with some new design components, and we just go back and forth and, show us the CAD design. They say, what do you think about this? Or what are some other considerations? Or if we're going to 3D print this, what material properties do we need? And so I love working on a team and kind of that back and forth, again, collaboration, because you can only get so far by yourself sometimes. And then it's that talking and that iteration that really can make you a great engineer, and you need others to do that. So that's my favorite part.
My favorite part is just continuing to learn. Like you always learn something in each design, and then you get new projects that are harder. So I'm constantly learning new things.
Yeah, and I like the part that you can build. It's not everything is in the paper, like on a paper, like I do create a model, do some calculations, and okay, everything is set and ready. I do simulations, everything is set and ready. But you actually go to the lab, build a prototype, and then you realize, oh, I missed this, I missed that. This is going to have a big consequence on the functionality that I was desiring. So again, I think that adds on to the points that you're constantly learning, improvising, and yeah, and actually building and testing. You can feel and touch, and if it actually works in the first go, that's probably the day when you're the happiest. So
Very cool. Okay, next question comes into Miriam Misek.
Hello, it's pronounced Michek.
My apologies.
It's okay. I get it a lot. So to preface my question, it's about business, but by business, I mean any aspect of your work. And it's also something that came from Maddie Trevison, but any of you three awesome panelists can answer it. And the question was, what kind of information is good to know for business decisions?
Thanks. So in my role, I deal with a lot of data, which we collect from testing, and a lot of these business decisions that the lab helps make is backed by that data. And I think that's the great thing of engineering is it kind of allows you to really investigate and make informed decisions. But then sometimes even then you have to make a little bit of a best guess. So an example is a lot of projects that we do in the lab are we collect data on something to make a standard. So for instance, like what is the range of test values that it's going to be acceptable for us to say, okay, this material is, good enough quality for our consumers. And so a lot of that happens way at the material level, even before the garment level. And so we have to collect a lot of data, analyze that data, and then say, okay, we think that this range of results is acceptable. And sometimes that means correlating the lab results to perception. So having, really real people look at it, or wear testing and figuring out that sweet spot for Nike to be able to say, okay, if it tests within this range, it is considered good. And then what is considered a failure. So a lot of that is what I do from day to day. And it's, again, most of it's informed by data, but sometimes when that perception component comes in, you just have to make kind of a best guess to move forward.
I guess I could say the city also, we have to make business decisions. We call it an NBCR. So we do net benefit cost ratio assessments for all of our projects, particularly when they get over $3 million. And that means we look at all of the risks and the future worth of a project. So should I rehabilitate, which means maintain the existing structure, but just kind of clean it up or align it to maintain the same host structure, or build a whole new alignment of pipe? And oftentimes you'll think that isn't a new product better because it means it's going to last longer, but what we rehab now is going to cost less later. So we look at those risks and the cost and future worth when thinking about how to move forward with the project, because our money is actually really important because it's your money or your parents' money, taxpayer dollars and ratepayer dollars. So we have to be very conscious of how we use that money. I have to say sometimes the way we use it, we don't always agree either. Even the amount of staff we put on a project, I don't want 20 engineers on a project if they're going to cost more than the actual construction of the project. So those are things we look at as well for personnel. I say that's the project management type of stuff in my role. That you'd be surprised how much of that is actually part of engineering when working for like a government entity or a business. There's a lot of project management.
Yeah, I don't have enough experience in this area, so I'll pass this question.
And I also don't want the panelists to feel like obligated to jump in for every answer. So there's no good way through Zoom to go pass, but we'll figure it out. All right, the next question is for Margaret Grace.
Yeah. Sorry, let me remember what my question was. Yeah. How would you recommend that someone like explores their interests without feeling like they're wasting time? Maybe if something like doesn't work out, but you still have to follow through with it, how do you feel like you're not wasting that time?
Anytime you're learning something, it's not a waste of time. Even if it's like you're stuck in an internship that maybe you don't like what you're doing, you're like, well, I have to finish it. It's still good for the resume. I've seen friends with 6-month stints on their resume. They just move around. It's not really a bad thing anymore. I think before it was. But yeah, anytime you're learning, it's not a waste. Because now you know I'm not going to do that again, or I'm going to find positions that make more sense, or I'm not a coder. I'm not going to try this again. That's what I learned when I was thinking about being a mechanical engineer. There's some programming, at least for robotics. And I was like, not for me. Wasted a year, but it wasn't a waste because I learned that I'm not great at it.
Yeah, I can add to that. So for example, I'm thinking of a research problem and I can easily spend days lost in that. And then in fact, only after 2-3 days, I realized, oh, I wasted so much time. I could have done this, I could have done that. But when I spent so much time, like say 5 days, 10 days, sometimes 20 days, there was nothing concrete that came out of like, I cannot say, okay, this works. Yeah, I can publish a paper on this. That doesn't always happen, right? Because again, I think to what Ms. Brannon said, as long as you're learning, you're good to go. As long as you're focused and you're learning and your desire is to achieve some approximate goal that you want to improve your life or the life of others, I think you can explore. Yeah.
And just to add to that, I would encourage you, even if you're ever in a position where, yeah, I don't want to do this the rest of my life, just still like do the best that you can, challenge yourself, don't give up, don't lose interest. Because not only are you building those skills, even if you figured out what you didn't want to do, you never know, like in building that network and those relationships, if someone that you're working with now might end up helping you connect you to the next step. So definitely kind of keeping that positive attitude and determined to learn as much as you can, no matter what position you're in.
Such good advice for everybody so far. All right, so Diego Romero is up.
Okay, so I guess my question would be, what was the most surprising or challenging problem that you faced at the beginning of your career?
So I can start. Believe it or not, I wanted to do journalism before I decided, okay, I'm going to do engineering. And that was really challenging. There you can see the dramatic difference between becoming a professor or becoming a journalist, right? So I think that was a good, challenging 6 months that I spent exploring what I want to do. And I think what helped me was talking to my mentor, who at that time was my father. And he had always guided me through my career. Uh, uh, and yeah, I think finding the solution was that talking to my father so many hours a day to figure out, okay, yeah, they're very different things, right? So yeah, it's funny how I jumped, but
To be a civil engineer, you have to have it's recommended that you have an engineer in training license. So you take a 6-hour exam. So it's like you finish the degree. That was a lot of work. And now you have an FE exam, Fundamentals of Engineering. So that was a struggle for me to do because I had jumped right into work while I was still in school. So finding the balance of having a full-time job and going to school and then studying for a test that they recommend 200 hours for was really hard. And I didn't pass the first time. And that was a struggle. A lot of it is just like blows to the ego, and that's humbling and really good. So that was a challenging problem. And then I went and continued to have the same problem because to be an actual engineer in Oregon and call yourself that in civil, you have to be licensed with a professional engineering exam. So getting a PE. And as of a month ago, I passed my PE. So I'm on my way to being a licensed environmental engineer. But that was an 8-hour test with over 300 plus hours. And it's really hard when you're going through buying a house and getting married and various things, but get it done as soon as you can, because the more life happens, the harder it is to focus. So that was the most challenging thing, because I was like, if I had known about this test, I would have switched my major to something without it, because it was that hard.
The only thing I would say is that, you know, versus previous internships I had where it was a limited amount of time, you know, given my project really early on and kind of was working on my project the whole time. A lot of times when you start full time, there's a training period involved and there's a transition where you're trying to kind of understand your role more and get used to, you know, weekly team meetings and kind of your place on the team. And so just kind of being patient. And it took me a little bit of time until I started working on projects that I was super excited about because of that transition period. But just understanding that that is, that's part of the job, and being, again, don't be afraid to ask questions, and just being able to find my voice in meetings, even though I was the new person, and then realizing, no, I think I should ask this question or I should make this recommendation. And everyone was really receptive to that. But at first I was a little shy, so don't be shy.
Okay, and my apologies. I try to go in order, but I did skip Micah. So Micah is next.
I apologize, my camera isn't turning on as well, but my question for you guys is, what do you see as the most promising innovation in engineering as of today?
Maybe I can go first. I would say there is no one, right? Because mechanical engineers would say something else, chemical engineers would say electrical. They would just, yeah, everybody would. So I would say, I can say in my area, right? Because that's where I specialize in. I would say in my area, it's the most challenging problem right now is related to climate change. And we as engineers, at least who have focused area where I work in, are trying to create systems that are highly energy efficient, greater than 99% efficiency, being power dense, being inexpensive, being reliable, and being able to reach widespread areas irrespective of socioeconomic conditions. So this may be in the form of designing electronic circuits, designing better batteries, designing recyclable, I would say, systems. So again, I would say there's no one solution or there's no one problem. At least that's how I look at it. But all of this can come together to meet one objective, that is, yeah, combating climate change is what I would say.
I would say infrastructure is in my field in civil. We have huge infrastructure dollars coming from the government, and a lot of the things in the systems, our roads, our highways, the way we treat our water. I mean, we have places that don't have potable, drinkable water right now. So promising engineering innovation is coming up with solutions that provide those services to people. Civil is the people's engineering. So it's not the most glamorous unless you're building a bridge. But again, when those things don't work, we are hugely impacted by that. And a lot of times there's just not money for it. And so seeing infrastructure dollars come through to help fix these things in a way that doesn't disproportionately impact or displace communities of color, or what we call frontline communities, low income people of color, that'll be interesting and innovative if we can design and build without displacement like we've done historically.
I would say in my industry, again, related to climate change, working at a large company, there's, it's inevitable you're creating waste. And so it is the responsibility of these companies to change their ways to minimize that as much as possible. Specific to textiles, there are a lot of, we're trying to implement more recycled materials. There's something called cradle to cradle, where the idea is you have something that is manufactured, made, used, worn, then sent back, completely broken down back into those parts again, and then used again. But the thing is, it's not possible for all materials, depending on what's in it, if there's any sort of plastics, whatever. And so eventually kind of moving more towards that will minimize waste a lot. And we're still working on it. And, there are some industry leaders that are kind of leading the way. So it's definitely very important to our future.
Thank you very much, guys. I appreciate it.
Okay, so looking at our remaining time, which is about 8 minutes, and we have at least 10 questions in the queue. So let's try some rapid fire. I don't know how well that'll go, but Clara Sawinski, you're up next.
All right, I wanted to ask, do you have any advice for high school that will help you succeed in college or in the workforce after college?
Ask for help. I would have passed calculus 2 a lot faster if I had just went to the math center and stopped feeling like I wasn't very smart. Asking questions is how you get smarter.
I would say time management. In college, you're not in class necessarily from 9 to 5. Sometimes you are, depending on your schedule, but you usually have breaks in your day. So figuring out what works for you. A lot of times for me personally, I studied in between classes. So I wasn't staying up until midnight because I knew that I'm a morning person and I need my sleep. And so figuring out what works best for you, and it takes a little bit of time to adjust, but if you're kind of on top of that, everything else falls into place.
Yeah, and stay motivated. As long as you're motivated, you will be motivated to ask questions and then essentially reach your goal. So if you are not motivated, yeah.
Very cool. Esther Solomon, you're up next.
My camera actually isn't working as well, but my question is, how did it feel environment-wise to transition from being an engineering student to holding a job in the field?
Most of what you learn in school doesn't directly apply to the job. And that was the biggest shock for me. Learning how much of the job is not really related to our classes, but is still engineering. And that makes me realize how much of a gap there is in engineering school to actual positions. So it's just constantly learning very quickly, trial by fire, but you're new, so no one's expecting you to know everything either.
So on my first day of my job, some mentor I really appreciate said that this is your first day of job. Even if you ask dumb questions, nobody's going to say that because this is your first day of your job. And that holds true for the entire first 1 or 2 years. So use that opportunity to ask even the most dumb or basic questions, because I think that's what I did. And probably 50% of the time, they did not even know because they did not revisit those ideas because it was the norm. So again, ask questions because it's the first day or first year of your job. You'll just get better and learn more.
And just to add on, I would say in college, you learn how to learn, and those skills are probably what's most applicable to your real job versus the actual content that you're learning.
Boy, do I agree to that one. Next up, Emma Holden.
So I kind of decided to change my question. Hopefully that's okay. But I'm stuck between two engineering majors. How do you decide what you actually want to do? Because like I can't decide. There's two I really want to do.
When you go into engineering school, you're all in the same first classes. You're all taking physics, you're all taking calculus, and a lot of times your school will have an intro to engineering and it'll teach you all the different fields. If you are interested in two different fields, bug some ACE alumni and we'll tell you about the different engineering fields and what we do. I'm going to put my email in the chat, but I run a society of engineers, so I can connect anybody with the type that you want, and you can just have a one-on-one to learn.
Yeah, quickly adding on to that, get some experience. Try to talk to the students who are working in that area, be it undergraduate or graduate, because then you will know what's there in the future. You can just visit their lab and just see what they're doing. How do they work? Where are they going? And I think that will probably help you. Just talking to students who are probably 5, 6, or 2, 3 years ahead of you.
Thank you.
All right, Diana Rodriguez.
So kind of like Emma's question, like why did you choose like civil engineering, like as an example, over like mechanical? Like why did you choose that specialty?
Well, I didn't know I could go into stuff like Nike and apparel design and things that are really cool. I just saw a lot of HVAC, which is airflow, and robots, and I wanted to do something that was really helping people, and that's why I picked civil. If I had known that mechanical is so broad, I mean, I probably still would have stuck with it, but like I said, civil is a people's engineering, and I've always been a little bit of an altruist. I love volunteering, and it makes me really happy to be able to improve civic things in our world.
Yeah, I'd say I didn't have it figured out. I didn't know what I wanted to do, but I had talked to some people that had majored in mechanical engineering, and those people I talked to were all doing very different things. So I kind of figured, start here. If I need to pivot later, I will, but it gives me the most options and just buys me time to figure that out. So that's just how it ended up for me.
Thank you.
All right, we should be able to squeeze in one last question before we all get kicked out. So Arden Lynch, you get to close this out.
Okay, my question was, what is something that someone has done that made you feel like you belonged on their team?
I can quickly say that I was working on a new student working in the lab. And like I mentioned, that I was the only female at that time. And my circuit, one of the components blew up and I didn't know how to fix it. I didn't know how to desolder. In that case, for example, it was like a giant 16 pin chip or something. And so I just went, asked for help. And one of the other students worked for like 4 hours to help me fix that circuit. That's the evening, basically, when I realized, oh, okay, I belong here. I can go ask questions. I can go help. And that just helped me, ask a lot of questions to different people. And
A lot of people asking me to coffee to learn about me.
Yeah, I would say the same. I think it's really important to get to know your teammates. And so being able to get coffee with them and understand them as people is probably the most important thing. And once you kind of form that relationship, then they are your teammates. You're going to want to, do everything that you can to do a good job for them. And that's personally what keeps me motivated. I love being on a team. So I do feel like I belong because of that.
Perfect. So 15 seconds, I'll do the closing. Thank you, panelists. Thank you, students, for your great questions. Enjoy the rest of your day with the Midsummer Conference. Hopefully you get a lot out of it. And for those that I know, I will see you soon.